Welcome to FORSEdu. In continuation to our series of total quality management, we will discuss in this video about 7 quality control tools. Quality control is essential for any business. It helps meet and exceed customer expectations. Kaoru Ishikawa of Japan suggested 7 simple tools that can be used for quality control through proper arrangement of data and its analysis. The tools are very simple and can be used for more than 90% of industrial problem solving. Let us now understand the quality control tools and its applications. Mr. Smith was the plant manager of a car manufacturing company KJS. He was getting a lot of complaints of quality check failures and hence wanted to understand causes. He used the 7 quality control tools to get a better visibility. Mr. Smith wanted to know how productivity is affected by the number of defects found in a day, so he decided to use a scatter diagram to help find him the relationship between productivity and defects. Scatter diagrams represents the relationship between 2 variables and shows the results on a Cartesian plane. It also helps in determining the correlation amongst the two, and it can used only for numerical data. The following scatter diagram of KJS showed the negative correlation between productivity and defects. He noticed that as the number of defects increased, the plant's productivity decreased and vice versa. Having decided to reduce the number of defects, he decided to take a systematic ways of eliminating the defects. First, Mr. Smith wanted to know the division and the type of defects occurring on the assembly line per day of the week, hence he decided to use a check sheet. A check sheet is a manual graphical method of data collection in a structured way. It is used to summarize the data and tally count of event occurrence, such as defects or non-conformance. Hence it is also called tally sheet. Whenever a defect is found, a tick/mark/update is made in the appropriate cell. It ensures fast, easy and error-free collection of data. In this case, assembly line worker identified the type of defects, vertically listed, and the days of the week, horizontally listed. Whenever a defect is identified on the assembly line, the value against the cells are updated. At the end of the week, a summary of the defects throughout the week is presented to Mr. Smith for necessary action. In order to understand the procurement of materials flow of KJS and identify the various requirements of each step, Mr. Smith decided to make a flow chart of the entire process. A flow chart is a graphical representation that lists the sequence of tasks to be performed to get the desired results. Flowcharts can also be used to show complex processes, and it provided a simple way of finding the relationships and dependencies between events. The connectors and shapes represent the type of actions to be performed in the process. Mr. Smith created the above flowchart to show the purchase process of KJS, and was able to visualize the entire process on paper. Mr. Smith was facing a challenge of variation in the level of defects in assembly line throughout the day and wanted to identify the time duration where the number of defects are high and when it is low. Hence he decided to represent the defects using a histogram. Histogram is a type of bar chart representing the frequency distribution in data. It represents the distribution by mean. If the data is normally distributed, the graph takes the shape of a bell curve. Histogram is used to measure or gauge occurrence of one variable against another. Always, it should be 2 variables. The y-axis shows the number of defects, variant, and x-axis shows the frequency of occurrence of the variance. Histogram can be used to identify where maximum or minimum variation is occurring quickly. Looking at the histogram, he identified that the defects are the highest during the initial hours of the shift operation and it was least during the ending hours. He realized that it was due to lack of concentration on the part of workers during the start of the shifts, so he decided to provide additional training and motivation to the workers. After having identified the various defects and the time when they occur, Mr. Smith now wanted to prioritize the reasons of defects. He doesn't have the resources to simultaneously tackle all the problems faced by KJS and decided to use Pareto principle to identify the problems to tackle first. Pareto charts are used for identifying a set of priorities, and is based upon the 80-20 rule, that is, a small percentage, 20%, of any given group accounts for higher amount of certain characteristics, 80%. It gives us information about vital few and trivial many reasons of defects. Hence it is also called vital few trivial many chart. He identified that the defects, incorrect screw alignment and mismatch in dimensions are the 2 most problem-causing, and maximum rejection of products are happening because of these 2 defects. A line drawn from 80% reject points locates these needs to be rectified first. Mr. Smith decided to use the cause and effect chart to understand screw alignment issue and control charts for mismatch in dimensions. Mr. Smith wanted to understand the various reasons for the incorrect screw alignment and find the root cause of it. He decided to use the cause and effect diagram for the same. It is also known as a fishbone diagram because of its shape, which is similar to that of the side view of a fish skeleton. It tries to establish a relationship between an effect and multiple possible causes for the effect. To develop a cause and effect diagram, a brainstorming session is required in order to come up with the various causes leading to the problem and determine whether the cause significantly contributes to the problem or not. After a meeting with his officers in the plant, Mr. Smith was able to identify the various reasons for the failure, namely men, material, measurement, machine, and method and screw alignment. This helped him pinpoint the reasons of the defect and take corrective measures for the same. Lastly, Mr. Smith wanted to monitor whether the dimensions of metal sheets used in the assembly line is within limits or not. So he decided to make use of control charts for this activity. The thickness of every metal sheet that was produced was plotted on the control graph. Control charts is a statistical process control tool used to determine if a manufacturing or business process is in a state of control or not. These charts help to identify the stability, predictability, common and special causes of variations in the processes. A control chart always has a central line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. He established the upper and lower permissible limit of metal sheets as 9.09 and 1.83 units and the ideal thickness as 5.46 respectively, and monitored all the sheets thoroughly for any anomalies. Through control charts he was able to understand the unstable points and unstable trends in the production of metal sheets. Hence, by using the 7 quality control tools, Mr. Smith was able to reduce and control the amount of defects incurs. That's it for today's video. Please like, share and subscribe to our channel. Stay tuned for our next video.